about electron configurations for neutral elements in atoms. Now we're going to talk about electron configuration for ions. So we've talked about ions before. It's when there's a different amount of protons and electrons. So if we have a positive ion, we're going to take away electrons from our electron configuration. If we have a negative ion, we're going to add electrons to our electron configuration. Because if it's positive, that means that there's more protons than electrons. So we don't need as many as electrons. If you have a negative ion, that means that there's more electrons, making it more negative, so we have to add electrons. So we're going to do some practice problems. We'll do one together, then you can do one on your own, and we'll keep going back and forth. So the way to do this, or the way that we're going to do it to make sure that you understand it, is we're going to do the neutral atom first, and then we're going to do the ion. So for chlorine, the regular electron configuration would be Ne. We're going to do our noble gas notation here. And it's going to be 3s2 and then 3p5. So that's for chlorine. For chlorine 1 minus, we're adding electron. So it would be Ne 3s2 3p6, signifying that there's one more. Another way to write this is just in the noble gas configuration, which would be Ar. So let's have you do calcium. So remember, we want to do the neutral one first, and then the ion. Alright, so hopefully you got the same answer as I did. For calcium, just neutral calcium, we have argon 4s2. Then for calcium 2+, we're going to be taking away 2 electrons. When we take away 2 electrons, it's getting rid of our S shell altogether, so it just leaves us with argon. Okay, so when we're dealing with the D block ions, we have to remember that our s electrons are going to come off before the D electrons. So in this case, let's do cobalt here. So let's write just our neutral one first. So we have, starting with our noble gas, and then we have 4s2, and then we have 3d7. So that's for our neutral cobalt. Now, if we're going to do cobalt 3+, we're going to take away our s electrons first, so that's 2, and we have to get rid of 1 more. So that's going to leave us with 3d6. So you're completely getting rid of your S, and then whichever additional electrons you need to get rid of, that's when you start taking it from your D. Why don't you try titanium on your own? So hopefully you got the same answer as I did. If you didn't, try to go back and compare it to cobalt, which we did together. If you still don't understand how we got this answer for titanium 3+, we can go over it in class. So we're going to be doing a lab. And for your pre-lab, you have to write the electron configurations for these 3 ions. So the first one is Fe3+, the second one is Ni2+, and the third one is Cu1+. So what you have to do is write out the electron configuration for them, and make sure that when you're doing it, you are taking away from the S block first, and then taking any additional ones that you need, or adding any additional ones that you need to the D block.